planet has hosted countless species of living creatures for millions of years. Many of these species have gone extinct, and over time, new ones have emerged, eventually leading to the world we know today. When we think of extinct animals, the first that come to mind are dinosaurs, and then, of course, mammoths. Today, we'll talk about why these animals went extinct, why scientists are trying to bring them back, and whether such a thing is truly possible. Before we begin, if you'd like to support the growth of our channel, don't forget to subscribe, like our videos, and share your ideas for new documentary topics in the comments below. Now let's travel far back in time, to the age of the dinosaurs. Around 66 million years ago, dinosaurs, which had dominated the Earth for about 165 million years and were mostly massive creatures, completely disappeared from the surface of the planet as a result of a series of catastrophic events. Because fossil remains are incomplete, we cannot know exactly how many dinosaur species existed back then. However, based on the fossils we do have, scientists estimate that around 1,000 species of dinosaurs lived on Earth 66 million years ago. Some paleontologists suggest that if all fossil evidence had been preserved, the number might have reached 3,000 to 5,000 species, while a smaller group of scientists believe the count could have been as high as 10,000 species. As we mentioned, the lack of complete fossil records makes it impossible to know the exact number. The extinction of the dinosaurs began when a massive asteroid named Chicxulub struck the Earth. This asteroid impacted what is now the Yucatan Peninsula in Mexico. If you ever visit the area, you can still see the enormous crater left by this collision. The asteroid was estimated to be 10 to 12 kilometers, 6 to 7.5 miles, in diameter and hit Earth at a speed of 20 to 70 kilometers per second. That's between 72,000 and 252,000 kilometers per hour, 45,000 to 157,000 miles per hour. That's an absolutely incredible speed, and for an asteroid of that size, unimaginably destructive. According to scientific analyses, the energy released during the impact was equivalent to millions of nuclear bombs. Imagine how devastating that would have been. If a similar event happened today, humanity as we know it would likely be wiped out. When the asteroid struck, many living creatures in the immediate area were killed instantly. However, the real chain of events that led to the extinction of the rest of Earth's life began afterward. The impact threw enormous amounts of dust and sulfate aerosols into the atmosphere, enveloping the planet in a thick, dark layer. As a result, sunlight couldn't reach the Earth's surface for years. The planet plunged into a global winter, and the lack of sunlight caused photosynthetic plants to die out. Plants are a vital foundation of the ecosystem. Their extinction triggered a total ecological collapse, leading to mass starvation across the food chain. As a result, about 75% of all terrestrial dinosaurs, roughly 2/3 of all life on Earth, disappeared. The asteroid's impact also caused global wildfires. Molten rock fragments were ejected into the atmosphere and fell back to Earth, setting vast regions ablaze. The oceans became dangerously unstable, producing massive tsunamis. As we mentioned earlier, one of the main factors that triggered the ensuing ice age was the sudden atmospheric heating after impact, followed by a long period of cooling. Eventually, most dinosaur species perished, and those that managed to survive the initial catastrophe later died out due to food shortages. And that, dear friends, is how a single asteroid impact managed to change the entire course of life on our planet. That brings us to the mammoths, the close relatives of today's elephants. Despite their massive size, mammoths have always seemed like gentle giants to many people. Unfortunately, their fate was destined to mirror that of the dinosaurs. However, unlike dinosaurs, the extinction process of mammoths was much slower, and in fact, they disappeared relatively recently in Earth's history. The most well-known species of these creatures is Mammuthus primigenius, or the woolly mammoth. Most people recognize it thanks to the beloved animated film many of us grew up watching. These giants could reach up to 4 meters in height and weigh between 6 and 8 tons. Thanks to their thick fur and an underlayer of fat that could reach up to 8 centimeters, they were incredibly well adapted to cold climates and even glacial environments. They also had those famous long, curved tusks that made them truly iconic. Their habitat stretched across Europe, Asia, North America, and even parts of Africa. An enormous range, as you can see. Most mammoth populations went extinct about 10,000 years ago at the beginning of the Holocene epoch. However, small groups managed to survive much longer, until about 4,000 years ago. Fascinatingly, a population of mammoths on Wrangel Island survived until around 1650 BC. This means that while the pyramids of Egypt were being built, there were still living mammoths on Earth. According to scientists, there were two main factors behind the extinction of the mammoths. The first was climate change. Since mammoths were highly adapted to the Ice Age, the end of this era transformed their vast grasslands into dense forests, making it extremely difficult for them to find food. The second factor was, unfortunately, humans. As you know, even today, many animal species, like rhinos, are killed for their skins, horns, or other body parts. The humans of that time relied heavily on mammoths for their meat, bones, and hides. They hunted these creatures relentlessly, pushing them to the brink of extinction. Although there were many other species available to hunt, humans had become extremely skilled and accustomed to hunting mammoths, so they rarely shifted their focus. People also played a key role in wiping out small, isolated mammoth populations. As a result of all these pressures, the species eventually went extinct. However, a new theory has recently emerged among scientists. It suggests that the DNA of the last mammoths on Wrangel Island showed significant genetic degradation before their extinction. This indicates that they became genetically weaker, more prone to diseases, less fertile, and less adaptable. While this may have reduced their numbers, some researchers believe it wasn't severe enough on its own to cause full extinction. Since mammoths disappeared relatively recently compared to dinosaurs, we actually know much more about them. Both of these extinct species, dinosaurs and mammoths, still have living relatives today. For example, Asian elephants share a very close genomic similarity with mammoths. Likewise, many modern bird species are considered to be descendants of dinosaurs. Because of these genetic relationships and advances in technology, scientists, theorists, and the general public have begun asking, can we bring these extinct creatures back? Scientists have identified three possible methods for de-extinction. The first is cloning. In this method, DNA from the donor species nucleus is inserted into an egg cell of a closely related species, and the embryo is implanted into a surrogate mother. Theoretically, this could produce a young individual with a full genome of the extinct species, but in practice, it's extremely unlikely to succeed. That's because most ancient DNA is damaged, incomplete, or fragmented. Even if successful, the resulting animal would likely suffer from severe health issues, and embryonic death rates would be very high. For instance, in 2003, scientists attempted to clone the Pyrenean ibex, or bucardo. The clone was successfully born, but only lived for a few minutes before dying due to serious lung defects. Because of such results, cloning is generally avoided today. The second method is selective breeding. This approach is more feasible and ethically acceptable, but requires a long period of time. In this method, scientists selectively breed living relatives over many generations to recreate the appearance phenotype of the extinct species. However, this does not actually resurrect the species. It only produces something similar. For example, a modern T-Rex created through selective breeding wouldn't be a real T-Rex genetically. Its genome would be entirely different. Still, this approach is generally viewed as more ethical since it doesn't directly manipulate DNA. The third and final method is genome editing. In this approach, scientists identify key genetic differences between the extinct species and its modern relatives, and then use CRISPR technology to copy and insert those genes. This method is currently being developed by George Church's team at Harvard and several biotech companies. The biggest advantage of genome editing is that it allows scientists to target specific traits like thick fur, body fat, and cold resistance, enabling faster and more precise results. It also helps bypass the issue of missing DNA segments. However, this method also doesn't bring back the exact extinct species. It merely transfers the extinct species' key traits into a living relative. For example, inserting mammoth genes into an elephant's genome could create a new species that is hairier, fattier, and more resistant to cold, essentially a hybrid between a mammoth and an elephant. All of these methods share major technical challenges. Ancient DNA is almost always damaged, incomplete, or degraded. No perfectly preserved nucleus has ever been found. Geneticists therefore spend enormous effort repairing and reconstructing genomes. Even if this genetic problem were solved, the embryo would face numerous developmental challenges, such as epigenetic errors, maternal environment issues, and embryo development complications. Each of these factors is critical for survival. Even if one individual somehow survives, it would still be impossible to restore a self-sustaining population. Beyond the technical hurdles, there are serious ethical concerns. Many people argue that humans should not interfere with natural evolutionary processes. They believe our efforts should focus on protecting existing endangered species rather than reviving long-extinct ones. According to this view, these recreated creatures would suffer because modern ecosystems no longer suit their needs, leading to long-term suffering and death. So now, we turn the question to you. Do you think these extinct creatures should be brought back to life, or should humanity leave nature's course untouched? So my dear friends, despite all the mass extinctions our planet has faced over the ages, life has always managed to find a way to continue. One day we too, as the human species, will eventually go extinct. Perhaps after us, new human-like species or intelligent life forms will emerge. And they might try to bring us back, study our DNA, discover the works we left behind, and maybe, just like we do today, create fantastic stories about us. That's all from me for today. I'm truly curious about your thoughts on this topic. Each and every one of you is a very valuable supporter of my channel. If you want to help our channel grow even more, don't forget to subscribe, like this video for more content like this, and share your new documentary ideas in the comments. I love you all. See you in the next video. Take care and stay safe.